Okay, picking up lesson 8.4, example 2A. Excuse me, 2B. We did 2A yesterday. We did a whole bunch of simplifying at the top of the page, right? It's always factor and reduce. Factor and reduce. We did our first multiplication. Again, it was factor and reduce. So, let's try B. X squared plus x minus 6. What do you know about that? It factors. Two parentheses. And if all else fails, that's what we're expecting to happen, right? So you at least need to be trying this. X squared. Everybody knows x squared is going to be x and x. Okay, no excuse not to be able to get that on your own. Okay, what about numbers here? In this case, my numbers have to
be 1 and 1 squared.
Yep. Add to be 1, multiply to be negative 6. So, if we're talking about multiplying to be negative 6, adding to be 1, we know we're going to have to use some combination of, I agree, plus and minus. I was thinking 2 and 3. So, both are true points, though. Okay, I was thinking some combination of 2 and 3 because 2 times 3 is 6, and 2 and 3 subtract to be 1, correct? Now, I agree plus and minus because it multiplies to be minus 6, right? So that's a positive and negative. Which one is which? Okay, because this is a positive 1, bigger number positive, so plus 3, minus 2. What about x minus 5 here? Yeah, it's just x minus 5. Because it's x to the first, the most you could hope for is a GCF. And it's just one x though, so there's not even a GCF. Okay? What about x squared minus 25? 2 parentheses again? Okay, x plus 5, x minus 5. It's the subtraction of 2 perfect squares. So the square root of x squared breaks into x and x. The square root of 25 breaks into 5 and 5. And because it multiplies to be negative 25, it's plus and minus. Okay? And denominator. X squared plus 4x plus 3. Again. Okay. X and x multiply to be 3. Pause right there. What multiplies to be 3? 1 and 3. 3 and 1. No decimals. If it multiplies to be 3, 1 and 3 adds to be 4. What about our signs here? Plus plus. Okay. There's the worst part of the problem, is the factoring. Yes?
Okay, so where it says x squared minus 25, I understand how to do that. Will it ever be a positive?
If that had been x squared plus 25, it is not factorable.
Okay.
So, in order to factor a difference of squares, it has to be subtraction.
Okay.
If you see a plus sign in this setting, you know that it does not factor. It would just have to be carried down as x squared plus 25. Yeah, it has to be a minus for that to work. And that's usually what you'll see at this level unless they're trying to trick you and they'll throw in the other one. So, okay, what do you guys notice? Yeah, we can cancel some stuff. What can we cancel? An x plus 3 on top cancels with an x plus 3 on bottom. And we talked yesterday, it doesn't matter. You can cross fractions, right? It's just that you're canceling bottom and top. X minus 5, x minus 5. Anything else? No. So what's my answer?
Sorry,
So,
I've got my iPad.
X minus 2 and x plus 5 are multiplied on top. Denominator is x plus 1. I wondered whose iPad it was. I figured they'd be back eventually. Okay, now, I'm fine with leaving your answers like this.
Oh. Cool.
What about Math Excel?
Yeah, it let me do that.
It let you leave them like this? Okay. Okay, so good news. You don't have to risk making mistakes and multiplying it out. You can leave it like that. Did you multiply it out? Ah. So, and it took it multiplied out. You didn't multiply it out. And it took it not multiplied out. Okay, so that tells me Math Excel's being flexible? What? Okay. Kind of a strange thought. I didn't know that could happen. But, yeah, so you could have foiled this out on top. X squared plus 3x minus 10. And that would be equivalent. Okay? But my personal thought is I'm more likely to make a mistake when I have to multiply it out, right? So I'd rather stop here at this step. Okay, are there any restrictions on the variable? Yeah, did we have some x's in the denominator? We certainly did. So if you recall from yesterday, we're going to set the denominator equal to 0. So what pieces am I saying equal to 0? Okay, x minus 5, x plus 1, x plus 3. All get set equal to 0 because they were all in the denominator at some point in time or another. Even though two of them canceled, they were in the denominator. So, x cannot equal 5, negative 1, and negative 3. Yes? In what we're doing right now, there's always going to be restrictions on the variable. Anytime x is in the denominator, there are restrictions. Even with division. Okay, so, and what we're doing, there's always an x in the denominator, so there's always going to be restrictions. Okay, on the back, there's 3 division. I'm not doing I wasn't planning on doing the word problem. I was just going to maybe do 2 of the division and then see if that gives you guys some work time today. Now, at the end of class yesterday, I think I briefly mentioned the difference between multiplication and division, right? With multiplication, factor, reduce, put it all in one answer, right? With division, what's the one thing we have to remember to start this off? How do we divide fractions? Okay, keep, change, flip is what a lot of you remember, isn't it? Meaning, you keep the first fraction, you change division to multiplication, and you flip the second fraction. It's always flipping the second fraction. Okay? And it is the same, officially, as your math teacher. I need to use the phrase multiply by the reciprocal. And I will say, as you guys get older, I try and use that more. You know, I would rather not have to say keep, change, flip, but on the other hand, if keep, change, flip is what you know and remember, and that's what's going to help you succeed, then let's go for it, right? I'm all about shortcuts too, so. Which means, the first thing I suggest you do is keep, change, flip. Now, how good are you? Can you keep, change, flip, and factor in the same step? Very possibly. You just have to keep everything straight, okay? For the benefit of teaching to the entire class, I'm going to do a keep, change, flip first. So I'm going to keep my first fraction as 2 minus x over x squared plus 2x plus 1. Division becomes multiplication. And then on my second fraction, it is the reciprocal. So it becomes x squared minus 1 over x squared plus 3x minus 10. And then we're doing exactly what we did on the front side of the notes. That's the only added step. Okay, is make sure you flip that second fraction. Other than that, it's a repeat of the front side. Now, of course, we have to start with an unusual one to begin with. 2 minus x. What do you know about 2 minus x? Is there a better way to write that makes you a little more comfortable? Okay. I would encourage you to think about it, whether you write it or not, and I'm writing it up here for the moment, as negative x plus 2. Now, what kind of factoring can I do on negative x plus 2? Okay. So, and some of you are going to say, there's nothing in common, which I agree. Other than the negative 1, there's nothing in common. I would encourage you to factor out a negative. Because when we factor out that negative, the remaining part could be something that could cancel. We're not going to have a negative x plus 2 down here in either of these. But if we factor out a negative, now, you can write it as a negative or you can write it as a negative 1. Personally, I'm perfectly fine with just writing it as factoring out negative. Would you prefer me to put a 1 there? I mean, it's the idea that it's a negative 1, if that helps, right? So if we factor out negative 1, this becomes positive x minus 2. And here's the deal. An x minus 2 might cancel, which is why we factored out that negative 1. Okay. Denominator. X squared plus 2x plus 1. Does it factor? Most likely, right? X squared is x and x. What multiplies to be 1? 1 and 1. And that just so happens to add to be 2. So x plus 1, x plus 1. Okay? My numerator is now x squared minus 1. How does x squared minus 1 factor? X squared is x and x. 1 is 1 and 1. And since it multiplies to be a negative, plus and minus. Denominator. X squared plus 3x minus 10. X squared, x and x, multiplying to be negative 10, adding to be 3. Okay? And I was going with some combination of 5 and 2. Multiplying to be negative means I need 1 negative, adding to be 3, positive 5 minus 2. Okay. What do you notice? What cancels? X plus 1. 1x plus 1 on top cancels with 1x plus 1 on the bottom. And 1x minus 2 on top cancels with 1x minus 2 on bottom. See, there was an importance in factoring out that negative, wasn't there? Okay. Now, at this point, just like we did on the front page, it's multiplication. Just put it all together. So, what remains on top that wasn't canceled?
Negative x minus 1.
Okay, a negative and an x minus 1. So I'm going to write negative, parentheses, x minus 1. What remains in the denominator? X plus 1, x plus 5. I would leave my answer like that. Why go to the extra work if we don't need to? Okay. Now, what are you guys going to tell me? We got to talk about restrictions on the variable. What have I been saying about restrictions on the variable? Okay. Set your denominator equal to 0. And what was it? Do you remember how I was saying that yesterday? We set the denominator equal to 0. It's anything that ever was or is in the denominator. Anything that ever was in the denominator. Which yesterday it just meant anything that is in the final answer or anything that canceled out the denominator. Yes? Here's the deal. When we look at our factor denominators, we think about these pieces right here, yes? But what else was in the denominator, however briefly? The top over here was in the denominator. It was brief, right? Because we flipped it right off the bat. But x squared minus 1 started in the denominator. So that counts as denominator. So when we do division, you have to set any original denominators equal to 0 and any new denominators equal to 0. Okay, so any original and new denominators equal to 0. So in my first fraction, it was always at x squared plus 2x plus 1, yes? So that means it was x plus 1 and x plus 1, which means I only need to set x plus 1 equal to 0. In my next fraction, I had x plus 5 and x minus 2 that I have to set equal to 0, correct? And what was in the denominator before we flipped it? X plus 1 and x minus 1, which I already have x plus 1, don't I? So I just really need to set x minus 1 equal to 0. So you might have a few added restrictions with division. So x cannot equal what? Negative 1, negative 5, 2, positive 1. Yes. Is this an emergency? Yeah. Okay, guys. Questions here?
Can we use some plus or minus on the one?
You could, yes. Yeah. I don't know why I haven't been writing plus or minus, but I haven't. But I'm fine with plus or minus. If you can find the plus or minus on Math Excel would probably be fine with plus or minus. Okay.
What's next?
7?
7.
Okay. Shall we try B? My plan was to try B and then let you guys have some work time. Unless you really want to try C also. B has the issue I want to talk about though. So B is the key here. Okay, guys. First question I would get in the habit of asking yourself. What type of problem is this? Division. Is that important to know? Yeah. Because if you treat this as a multiplication problem, you're going to be in a world of hurt here. So, what's the first thing we're going to do because it's division? Keep, change, flip. So, I'm going to keep x squared plus 5x plus 14 over x squared plus x minus 12. I'm going to change division to multiplication.
Did you say 4 or 14?
4.
Sorry.
I would have figured out a mistake here in a moment.
Oh, sorry.
No, you're good. Thank you. Okay, let me try that again. X squared plus 5x plus 4, correct? I must have said 14 because I wrote 14, so my apologies. Thank you. And then x squared plus x minus 12. Okay, so there's my first fraction. Then times, and then flip it, so 2x squared minus 6x over x squared minus 1. However you handle your keep, change, flip, you've got to remember to flip. Whether you do it now, whether you wait and do it as you factor. Okay. Well, the first fraction looks easy enough. X squared plus 5x plus 4. That's in that typical 2 parentheses form, right? X squared is x and x. What about numbers? Multiplying to be 4, adding to be 5. It's going to be a plus 4 and a plus 1. Okay, denominator. X squared plus x minus 12. Again, 2 parentheses set up. X and x. Multiplying to be negative 12, adding to be 1. It's a 4-3 combo. Positive 4 minus 3. Okay? Second fraction. 2x squared minus 6x. GCF. Okay, keep in mind, this is not a 2 parenthesis type thing. Because for it to be 2 parentheses, there has to be a constant. I've got an x squared and an x term. So we're thinking GCF here. Both terms have a 2, and both terms have an x. So we're going to factor out a GCF of 2x. 2x squared divided by 2x leaves me with x minus 6x divided by 2x leaves me with 3. Now, that 2x is probably there to stay, but that x minus 3 could be canceled eventually, yes? So that's why it's important that you see that GCF. And what about x squared minus 1? X and x. 1 is going to be 1 and 1. Plus 1 minus 1. Difference of squares again. Square root of x squared is x. Square root of 1 is 1. Okay. It's always good news if I see some canceling. What do we see? X plus 4. X minus 3. X plus 1. Canceled out the whole fraction. Yep. We are left with 2x over x minus 1. Okay. What do you guys have in the way of variable restrictions? Should have about 5 of them. Did you come up with 5 different numbers? You should come up with 5 unique ones. There's actually 6 pieces I would set equal to 0.
I see the one I missed.
Yeah, there's one we need to talk about here. Okay, so the first in the first fraction is just the one it's just the denominator, right? So x plus 4 and x minus 3 are the pieces we need to consider, correct? That's my first fraction. In the second fraction, we need to talk about the denominator we ended here with, right? Which is x plus 1 and x minus 1. And what can you not forget? What started off as the denominator? And that was the 2x squared minus 6x, right? Which is now the numerator. And so we're going to set 2x equal to 0 and x minus 3 equal to 0. So I just wrote out 6 things equal to 0, but one of those was a duplicate, right? I really don't need that one. That's a duplicate. So what are my variable restrictions here?
3,
Negative
1, 1,
plus or minus 1
and 0.
and 0.
Okay, so the obvious ones, 3, -1, 1, and -4. Those are the obvious ones. Did everyone get the obvious? And then what happens when you set 2x equal to 0? Divide by 2, and 0 divided by 2 is 0. Okay, when there's no plus or minus, it's going to represent a 0. So thus, you have 5 unique values that are restricted. Okay? You guys have just under 15 minutes. Can you use it?
Can he fix it?
Okay. Finish up lesson 8.4 for tomorrow in Math Excel.